Okay, so we're gonna talk about a new way to solve a system of equations. So graphing works when it's a nice point and we have access to a graph. Substitution works really nicely when we have them be able to be an x or a y equals something, but that doesn't always happen, right? So there's this process called the elimination method, and the elimination means to, like, you're literally going to eliminate something, right? So the elimination method is when you're going to get rid of a variable by adding the two equations together. So we're going to take 2 days on elimination. Today is going to be like the real basics, kind of easy stuff, and then it will get more difficult, okay? So just like with substitution, I'm going to give you guys the steps to solving, and then we'll kind of do an example. Next is the last time I see you before break, so that Thursday, I think, before break. Okay. Okay, so the steps to solving, we're going to, for number 1, identify. Ooh, that is not working well today. Identify or create, and which we're not really going to do too much today, but I want this to apply for both days. A variable that could be eliminated. And this will probably involve sometimes multiply by -1 or another number. Step 2 is you're going to add the equations together. Step 3, solve for the remaining variable. And then 4, just like in substitution, you're going to plug that in to find the other variable. So plug an answer into an original equation. To find other variable. Usually people like elimination better than substitution, which is why we wait until later to do this. All right, so looking at example A, says to identify or create a variable that can be eliminated. So we're looking basically for things that match in both equations, but match in that they're opposites of each other versus negative versus positive, right? So in example A, see how the top equation has a negative x, but the bottom equation has a positive x? If I add those together, what happens? Exactly, they cancel out, they eliminate. So we've identified our parts, so we're going to just add the equations together. So we're going to take these two things and we just kind of add straight down because I've organized it that way. If it wasn't set up where the variables line up, you just rearrange it yourself. So the x's just go away. And so I get 2y plus 3y would give me 5y. Negative 14 plus 9 gives me negative 5. So that's step 2. Step 3 is just to solve for the variable. What would I do to solve for the variable? Yeah. Exactly. Yeah, I'm going to divide by 5. Boop, boop, boop. So what's y? Exactly. Negative 1. So that's the end of step 3. Then step 4, just like always, we take it and plug it into one of the original equations and solve for, in this case, x. Which equation do you want to use, the top one or the bottom one? Bottom, okay. So we've got x plus 3, and then instead of y, I put negative 1 equals 9. And then I just solve. So I get x minus 3 from multiplying those. Then I'm going to add my 3. So x equals 12. So my answer is 12, negative 1. So example B, looking at those, what do you guys notice? Yeah, we got the 5 y's, right? But they're both positive. So that presents a little bit of a problem because if I add those equations together as they are, I'm going to get 10y, which doesn't really fit my purpose, right? So this is where on step 1, I say that you might need to multiply by negative 1 or another number. So if you just need them to be opposites of each other, you're just going to multiply by negative 1 to one of the equations, and it'll get it ready for you. But because when we're manipulating equations, you need to make sure that it goes to the whole equation and not just part of it in order for it to like stay equivalent to it. So, yeah. Which equation do you want to multiply by negative 1, the top or the bottom? Top? Okay, top it is. So how I like to show is I put little parentheses around it. I got my negative 1. And then I'm going to be like, okay, here's my new one. So I get negative 3x minus 5y equals a positive 14. So it just turns opposite of what it was, right? So now I'm going to take my new equation and that bottom equation. So I'm like done with that, right? So I add straight down, what is it going to give me?
Negative 5x plus y equals, I don't know.
Yeah, close. The y's go away though, right? So the 5y and the negative 5y go away. Yeah, Jordan.
Why did we times it by negative 1?
Because both of the 5y's were positive, and I need one of them to be negative to cancel out. Okay. Yeah, because when I add 5y and negative 5y, those go away. And then I add the 26 and the 14, which would be, what, 40? Okay. And then solve, right? So divide by negative 5. So what's my x?
8.
Yeah, negative 8. Okay. So now what do I do? Exactly. Plug it in. Which equation? Oh, and again, I do always recommend you guys using original equations because we know that they're correct. Which of the two original ones do you guys want to use? The top? Okay. I'm going to make that visible again because I crossed it out earlier. All right. So 3 and then parentheses, my negative 8 because it's going in for x. So let's see, I get negative 24 plus 5y Okay, so now what? Good. So I get 5y equals 10. So y equals what? Yeah. So my answer is -8, 2.